this problem is based on the collisions. Okay, let us see the problem. A fireworks rocket is moving at a speed of 45 meters per second. The rocket suddenly breaks into two pieces of equal mass, which fly off with velocities v1 and v2 as shown in the drawing. What is the velocity of v1 and v2? See, this is the fireworks rocket, and after moving some distance, it breaks into two pieces. Okay, and now what I am doing is, to make the things simple, I am taking the mass of the rocket as 2m and then fragments as m and m, because he is saying that each fragment is same mass, having the same mass. That is why if I take the initial mass of the rocket as 2m, the fragments will become m and m. Together it will become 2m. Okay, so that is the mass part. And then next, coming to the direction. If you see this rocket, it is making an angle with the horizontal. Suppose if this be the horizon, this is the angle. Okay. So if I consider that, then the problem again becomes complicated. So what I did is, I just took the direction of motion of the rocket as the x-axis, one of the axes. Okay. And then so afterwards, once it breaks into pieces, again they make some angle with the x direction and y direction. Okay. And so the perpendicular direction I made as y. So I have drawn the same drawing with my axis for the simplicity, okay, to make that problem simple. Now I have to, obviously this is an inelastic collision in 2 dimensions, and I have to take the conservation of momentum. You know, whether the collision is elastic or inelastic, momentum is conserved. So even though it is inelastic, this is an inelastic collision, the momentum is conserved. Right? Taking the conservation of momentum principle, I will try to find out the velocities v1 and v2. Okay. So here I wrote sigma p is equal to 0. This indicates that total momentum of the system is equal to 0, which implies that initial momentum is equal to final momentum. Here, so I have to resolve the momentum into two components, x component and y component. Now, if I write the x component momentum, initial momentum of the rocket is 2mvi. Momentum p is equal to mv. Okay, mass into velocity. Therefore, initial momentum of the rocket is 2mvi. Now, what is the momentum of the fragments? Both are making two different angles both are moving with two different velocities, making two different angles. So what I did is, first one is mv1 cos 30 degrees. He gave the angle. That is why it is making 30 degrees with the x-axis. I am taking cos because the angle is adjacent one. Okay. So the adjacent part is adjacent to the angle is cos component. Therefore, it is mv1 cos 30. Similarly, this will become for v2. This is mv2 cos 60. Now, I am taking the perpendicular direction as the y direction, and then I am trying to resolve the momentum into y components. I am taking the y component moment. Initially, the rocket is moving along the x direction, therefore it has no y component momentum. Okay, so it is 0. Now taking the y component momentum for the fragments, the first one will be, because it is, if I draw a line, it will go in this direction. Okay, so this is opposite side, therefore it will be mv1 sine 30, and then it will be in this direction. Okay, this is the downward direction. This is upward direction, and this is the downward direction. Therefore, what happens is, this is the downward direction is negative. So mv2 sine 60. Okay. Therefore, 0 is equal to mv1 sine 30 minus mv2 sine 60. What I do is, I will take this into other side and then solve for v2. v2 is equal to, m is not equal to 0 because m cannot be 0. Mass cannot be 0. So I am equating the remaining ones to 0. Therefore, v2 sine 60 is equal to v1 sine 30. From this, v2 is equal to v1 sine 30 by sine 60. Now what I do is, I will substitute this V2 value in the first equation. And then plug in Vi is equal to 45 because he already given the rocket is flying with a velocity of 45. So I plug in that value and then solve for V1. Once I solve for V1, I substitute V1 value in the second equation. Okay, third equation. I will put this as a third equation. Okay. Substituting this value in equation number 3, I will get V2. This is how I did. Just to make the things simple, then it will be easy. Otherwise, if you take this as the x direction and then it is making an angle and he hasn't given any angle, then the problem becomes complicated, too complicated. And then we can't solve this one at all. Okay. So, hope this helps. Thank you. Bye-bye.